Okay, so let's jump to a new thing. And this might be the final thing. Okay, so let's look at what is called, let me adjust my things more. Okay, so we talk of linear regression. Now, we learned or we went through something called linear regression, whereby we dealt with a table of which we had two columns, of which we will have a dependent variable and an independent variable. We had y and x. And through that, we are able to have some values so that after we be able to get these values, we use it to get a hypothesis function or a model equation. So we were modeling the equation ourselves. But this time around, within this machine learning linear regression, finding this is very easier. So remember, we were having y to be given by b. I remember we were having b naught multiplied by x plus b1. Wherever you put the b1 and b naught, they are the same. The only thing is that one is attached to the x and one is not attached to the x. The one attached to the x is the slope. And the one without the x is the intercept, as simple as that. So it's the same thing we are dealing with here. We have our theta 2 and we have our theta 1. Theta 1 is the what? The slope that is found here. Then theta 2 is the y-intercept, simple. So we say linear regression is used to model the relationship between what? An independent variable and a dependent variable. We've done that. The independent one is the one that we put inside the equation to solve for the output, which is the what? The y, or the outputs. So linear regression finds a straight line that best fits the what? The data. So you have to memorize this equation very well. Y hat is always equal to what? Theta 1 multiplied by x plus theta 2. So this is the what? The hypothesis equation for linear regression under this machine learning. Right. So let's explain then. We say that the theta 1 is the slope. What does it mean? It's changing y over changing x. Y over here, then changing what? X. So it tells you that whenever x moves by a point of 1, how does y also move? So if the slope is 2, it tells you that whenever x increases by 1, y will also be increasing by 2. If you have theta 1 to be equal to maybe 10, it tells you that whenever x increases by 1, y will increase by 10. It goes that way. But if the slope is 1,000, it tells you that whenever x increases by 1, the what? Y will increase by 1,000. Simple. Then what is the intercept? Intercept is the same as x to be equal to 0. When we draw the graph this way, the intercept is where the graph is cutting the y-axis. So at this point, you see that when you try to label this axis, this place will always be what? 0. So this is where at the value of, if x is what? 0, that is where we trace and see the y-intercept. That's why we always call that line x equal to 0. It's simple. So that is our theta 2, and theta 2 is our intercept. That's all. Now let's look at real life. We try to predict the amount of electricity that we'll use to heat to a particular temperature of water. So we try to plot a graph like this. Then we say that if the person need maybe a particular temperature, if I need maybe 26 degrees, how much electricity am I going to use? Is it 100 units? What about if the person need 54 degrees? I think it will increase. Maybe the person will heat up to what? He will need an electricity demand of maybe 200 units in that order. What about if the person needs 60 degrees Celsius? He will need maybe 300 units in that order. So you see that this thing is a linear relationship. As the temperature or as the amount of what? Temperature that we need is increasing. I think I've turned the whole thing. So let me delete it and do the right thing. Let me pick my eraser and take everything off. So the down there should be the temperature, whilst top there is our what? It's our energy demand. It's just simple. So let me just continue. I think this thing shouldn't be any problem. So let's plot it again. This place becomes our energy, the energy that we need. Then this place becomes the temperature. So if the temperature, I need 60 degrees, how much energy do I need? Maybe 25. If I want maybe 100 degrees, how much energy do I need? If I need 200 degrees, how much energy do I need? So it's the same thing, the same explanation. So our x-axis will become the what? The temperature. Then the y-axis becomes the what? The energy that we need to do the work or amount of electricity. So that is the explanation here. Our theta 1 is just telling us how much, because theta 1, as you remember, is our what? It's our slope. It tells you that per an increase of temperature, how much does the energy increase? That is the slope. Then our demand is where temperature is equal to 0. Our what? Our slope, our what? Our intercept. The intercept on the y-axis, it tells you that where the graph has cut the vertical axis, at that point, temperature is equal to 0. What value is there for the electricity demand? When we trace that value, that is what we call our theta 2. And this theta 2 is our what? Is our intercept on the y-axis or on the energy axis. Simple. So this one will control the what? The steepness of the what? Of the line, because it tells us the slope, how much this the dependent variable will increase whenever the what? The independent variable increases. So all these ones, the theta 2 shifts the what? The line up or down. So always when you look at it, it will either be here, it will either be cutting it here, or it will cut it here. So that one, this interpretation is not anything difficult. So let's take a practical example. How do we tackle such a question over here? Now, you see that we have been given a particular graph, and this is what goes on. Look at what they have given us. We've been given theta 1 to be equal to 0.05. Then we are given theta 2 to be equal to this. Already we know the equation. Y hat is always equal to theta 1 multiplied by x plus theta 2. So immediately you are given something like this, you quickly insert these guys there. Now our y hat will now be equal to, what is theta 1? That is 0.05. Then you have our x plus, then on our theta 2, remember it is minus, so this plus will go away, so that it becomes minus 1.9. So we no more have the plus over there. So everything will rather be what? Minus 1.9. Simple. Now what we are having is this. Can we now use this to solve a question? Because you can now use this one to predict. Now let's continue. Then we are saying that from the scatter plots, we want to check something. We already have the line of best fits as this. So these are the values that I've already explained. I've explained this, I've explained this. So we put it in the form of the equation. So the equation has already been done over here. We know this equation. So everything becomes this, as I told you. Fine. Now let's see. Now we are going to look at it. If we want to test for maybe the time that the temperature is 80, if the temperature is given by 80, can you put it inside this equation and get it? You see, this is the equation. And the value for x has been given as 80 degrees because the x is the horizontal axis. The x is the horizontal axis and the y is here. So if the x has been given as 80, it tells us that we are going to look for wherever there is x, then we put our 80 there. So if I try to do that, I'm going to have a value of, I put the 80 here, multiply by 0.05, I get 4. Minus 1.9, I get 2 gigawatts. Now, this is the answer that I've gotten. But let's go to the graph and see what is also there. Already, this is when we use our calculation. But when we look at the graph straight away, there's something that we get. If I trace like this, I'm going to trace to my left, then I'll have a value of 2.1. So you see, when we look at the actual thing, we are having 2.1. And when we also did our calculation too, we are still getting 2.1. So as I said, anytime you have something like this, you have to look for your error. The error is the same as the residual, which is given by the actual value minus the predicted value. And when I subtract this, I'm going to have 2.1 as the actual one that we got from the graph, minus the same 2.1 because we had 2.1 as our predicted value. So when we subtract, we get the error to be what? 0. As simple as that. So there is no error in this kind of what? Prediction. Now, there's something we call mean square error, or we have root mean square error, but we will tackle the mean square error first. So let me compile this one too for you so that I'll deal with that one too for you. Thank you.